Hello students, in this video we will discuss the series method. Okay, and we have already done the series procedure and method, and now in this video we will discuss some problems. Okay, now we take the example from the MMP barrier boast is x and y dashed is equal to xy and plus y. Okay, this is the example, first ones. Now we solve this differential equation by the series methods. Okay, then xy dashed and minus xy minus y is equal to 0. Okay, and then we take a solutions for this differential equation is we have already discussed, and y is equal to n 0 to infinity and cn x to the power n. Okay, and then we differentiate first time, and then this is equal to n is equal to 0 to infinity and the x to the power n and s1 and x to the power n minus 1. Okay, we take the derivative of this, and then we will get this. Okay, now we put this value to and to this equations, and then we will get this is x, and from n goes to infinity ncn x to the power n minus 1 and minus x, and then the value of y is summation from n is equal to 0 to infinity and cn x to the power n, and then minus the value of y is n is equal to 0 to infinity cn and x to the power n is equal to 0. Okay, now we multiply this x to this, then from n is equal to 0 to infinity n and cn and x to the power n. Okay, this is cancelled to this, then and we multiply this x to this, then we can write summation from n is equal to 1, and here this is start from 1. Okay, up to infinity and cn and x to the power n plus 1 minus summation n and x to the power n is equal to 0. Okay, and then we first observe the power of x when we put the limits value here, and when we put the value of limit, then this is 1. Okay, and here this is also equal to 1 and this is 0. Okay, now we can expand one term, then the power is become equals. Okay, and then this is minus c naught, we take first this term and then we write this term. And here we expand one term, then it will start from n is equal to 1 to infinity and cn and x to the power n is equal to 0. Okay, then here the c naught is equal to 0. Okay, from comparison both sides, then this is equal to 0, and then and here the n is equal to m. Okay, then the limits of the n is also for m, is the limits is also start from 1. Okay, this is for this integral. And now for this, and then the n plus 1 is equal to m. Okay, and then n is equal to m minus 1s, and the limits of m in here, when we put n is equal to 0, then the limit of m is equal to 1s. Okay, and then let us look here. The n is equal to m's, and also the limit is 1s. Okay, then we will put here, and this is 0, and then the m is equal to 1 up to infinity, and this is m, and cm and x की power m minus m is equal to 1 up to infinity, and here this is n plus 1. Let us look here, this is m minus 1s. Okay, and then x की power m, okay, and minus summation from n is equal to 1 to infinity, and cm and x की power m is equal to 0. Okay, and then we take the summations from m is equal to 1s, and here m, okay, and cm, and then minus cm n minus 1s, and minus cm. Okay, and x की power n is also common. Okay, this is not equal to 0, no, then this coefficient is goes to 0. Now then this mcm minus cm minus 1 minus cm is equal to 0. Okay, then we will take here the cm is common, cm into m minus 1s. Okay, this is minus 1s, and we transfer this term to this side, and then this is equal to cm minus 1s. Okay, then the cm is equal to cm minus 1 divided by m minus 1s. Okay, then we put the value of m, and we get the constants to c1, c2 and c3. Okay, and first we put the value of 1. Okay, here we cannot put the value of m is equal to 1 because this is infinity. Then we put the value of m is equal to 2, this is c2, and here this is c1 divided by 1s, and then this means that this is c1s. Okay, and then c3, then here is c2, okay, and divide by 2, and here we put the value of c2, then this is c1 divided by 2. Okay, now c4 and c4, then this is c3 divided by 3. Okay, and put the value of c3 here, then this is c1 and divide by 6. The 2 is multiplied to 3, and this is, and c5, then this is c4 divided by 4, and this is looks here is c1 and multiply to this, then this is 24. Okay, now we know the its solution is y is equal to the summation of n is equal to 0 to infinity cn and x की power n. Then we put the value of n is equal to 0, 1, 2, 3 up so on, then this is c naught c1x, c2x2 plus c3x3 and c4x4 up to so on. Then we put the value of constants. Now this c0 plus c1x, and then we put the value of c2, then this is c1 x2, and the value of c3 is c1 divided by 2 x cube, and then c4 is c1 divided by 6 x4, and then the value of c5 is c1 divided by 24 x to the power 5, and so on. Okay, then we take commons. Here the c0 is 0. Okay, we have already discussed this. This is 0. Then we take common, the c1x is a commons. Okay, this is become 1, and this is x plus x square divided by 2, and then x cubed divided by 6, and this is x4 divided by 24 up to so on. Okay, then this is c1x, and this is equal to the series of the e to the power x. Okay, then this is the solutions. Okay, this is the solutions. Okay, now this is this the series method. Now we solve this differential equation by the elementary methods. Okay, now we solve these equations by the elementary methods. Then we use the separator variable method. This equation is the x y dash is equal to x y and plus y. Okay, then this is x y dash is equal to, we take common y, and this is x plus 1. Then this is ty divided by dx. This is ty divided by dx, and y and to x plus 1. Okay, then y is divided here. This is dy divided by ty divided by y, and then x plus 1 divided by this x and dx. Okay, now we can write here, this is dy divided by y, and this is 1 plus 1 over x and to dx. Okay, and then we integrate, and this is the natural log of y. Okay, and here this is x, and this one is the natural log of x, and constant of integration is also right in the natural log of c. Okay, then we take the its anti log, then this is ey is equal to e to the power x, and this is and cx. Okay, when we take this in the natural log of c, we can also write like this. Okay, and then we take the natural log by e, then this is cancelled, this is equal to cx, then this is cx and e to the power x, and both have the same solutions. Okay, let us look here, and we can also says this is c1. Okay, then this two is become equal solutions. Okay.